Hello guys. So now we are going to start with one of the very important chapter of physics. In fact, we can say that we had started with physics finally of 11th class. Previously we had done mathematical tools which are required to understand and crack this physics. Now this is you can say that you can get a real feeling of physics. So this chapter is kinematics. Kinematics. And what we actually learn in this part of the physics, actually this is a branch of physics which deals with actually motion of a body. It deals with motion. I use a word motion, I will define it. Motion of a body. Okay. Then there is we all studied in mechanics. So we are started with mechanics and we are dealing with one part of mechanics, that is kinematics. So here we deal with the motion of a body. So before starting the motion, I have to define two terms, motion and rest. Okay, these are the basic terms, but I think I need to define them. Okay, so you must know them. You have seen it or observed these terms before in your previous classes, previous experiences. So motion, what is a motion? So motion is when we say a body is in motion, when a body does not change its position with time, then we call it at rest. When it does not change its position with time, when a body changes position with time, we call it the body is at motion. Position with time. Another thing is position with respect to something. Okay, when I am saying position, it is a relative term. So whenever you are talking of position, you should also be talking of some reference point. Okay. So the simple thing is, whenever a body does change its position with respect to time, we call it the body is at motion. And when that body doesn't change its position with time, we call it that body is at rest. Okay. Okay then. So to actually deals with the motion. Now let's come to the main point, motion. We have to deal a body is we have to study a body which is in motion. Now how do we actually study motion? So just first question should be like that. What would be our way of or what would be the tools to actually learn motion? So what would I say? So there are different tools to learn motion, and we deal motion of a body by studying or learning those tools. Say for example, a body is in motion. Okay, and how do we actually know what another body is in motion? Say body A and body B, both are in motion. Then how do we actually quantify the motion of A and B, or differentiate between the motion of A and B? So for that we have different quantities, you can say that, or parameters. And what are these? So let's talk about them. So different parameters to actually quantify motion. First one is the distance and displacement. So let's have a small chit chat over them. Distance and displacement. I think you have known about it. You have encountered these terminology before. So let's talk each of them. Like the distance. If I'm talking of the distance, so what is the distance? It is actually the length of the path traveled by a body. Length of path, actual path, actual. I must stress over this word, actual path traveled by a body. Okay, say for example, a body is going like this and this. There's a body is going like this, from this point to this point. So this is What is the distance? So you need to measure this spiral or zigzag path. You have to measure actually the length of this path. That would be the distance, and unit would be, of course, meter, because it's the length. And it is a scalar quantity as well. It is a scalar quantity because it's just a length, and unit is meter. But if I'm talking of displacement, so see the word, it is talking over the how much the body displaced, how much it is displaced. So displaced from where to where? If somebody says displaced, so your question will be from where to where? From initial position to final position. Okay, or you can take, here I'm taking initial position as a reference. It can be some other reference as well, but the thing is, displacement is to actually tell you the displacement, just join the initial position and final position. So it's the straight line path. It is the straight line path, length of the straight line path joining the initial position and the final position. Okay, it is a vector quantity, and as it is a length, unit is again meter, and it is the length of the initial position and the final position, the path, straight line path between the initial position and the final position. Okay, I hope you understand the difference between distance and displacement. If not, it would be more clear with an example. So I'm giving you one example. Just let me link it with shape. It is linked. Okay, so say for example, if I say there's a clock. Okay, there's a clock. So it's like 3 o'clock AM. So it is the 3 now. So what my question is, when it becomes 3:15, you have to tell me the distance and displacement of the tip of the mirrored hand. Distance and displacement of the displacement. Just give me one second. Distance and displacement of the tip of mirrored hand. Okay, just try it. So now let's think over this. If I'm talking about the distance, the tip of the mirrored hand goes like this. Okay, so this is quarter of a circle. True. So you just need to find the quarter of the circle. Say for example, the mirrored head length is 1 unit. Okay, 1 meter. Say for example 1 meter. So distance would be, is quarter of a circle. Whole circle length is 2 pi r. So quarter of a circle length would be, half circle would be pi r. Quarter of a circle would be pi r by 2. Quarter of a circle. That's mean 1/4 of a circle. So distance would be, just you don't need to do anything, pi r1 2, pi by 2. But if I'm talking of the displacement is actually, you need to, this is the mirrored hand goes from there to there. So final position, initial position, join them. So this is the displacement. Now how do you solve it? Say for example, can you see that this is a triangle? This is a triangle, right angle triangle. This side is 1, this side is 1, both are mirrored hand. So you just need to find the hypotenuse. You can use the Pythagoras theorem. Okay, use the Pythagoras theorem. So it would be, if you use the Pythagoras theorem, it would be 1 1, this 1 1, and this would be root 2. Pythagoras theorem is like 1 square plus 1 square is actually hypotenuse. Hypotenuse is actually this and this. So this would be root 2. So that is actually your displacement in this case. I hope you just got clear more with these things, distance and displacement. Okay. Okay, let's move ahead and discuss more in this case. Okay, in fact, I before moving further into advanced topic, I just talk about a simple topic: speed and velocity. Okay, we'll also talk about this. So speed and velocity. Speed is actually rate of covering distance per unit time. So if I'm talking about distance over time, is the speed. Actually, rate of covering distance per unit time. You have to just divide with the time. A time interval actually. Yes, we are talking over an interval. It is always a time interval. Velocity is displacement over time. Displacement over time. Over time. Okay. Now, when I'm talking of velocity, say for example, a unit. This one is the scalar quantity. This one is a vector quantity. You know it. This is linked with the distance, so it's a scalar quantity. This is linked with the displacement. It is a vector quantity. Unit is meter per second. Simple, meter per second. Okay. So I'll ask you something, and you need to think over it. Say for example, you are going from some place in Delhi to Kota. Okay. This is just a practical example of your day-to-day life. Practical example, you're going from Delhi to Kota. From Delhi to Kota, famous city Kota. Okay. And it's like 600 kilometers. And you just travel that distance in, I must say, 10 hours. And suddenly when you reach the home, your father asked, son, what was your speed? What was your speed? Now you are confused. You haven't seen the speedometer all the time. So you know distance over time, one formula for speed. So what you did for calculating your speed, you just did one thing, the distance, the time, you divided them 60 kmph, kilometer per hour. So you said my speed was 60 kilometer per hour. You go with the math. You went with the math. So my question is, was your speed 60 kmph? You said no, it was somewhere, it was 50, somewhere it was 100, somewhere it was a crowded market, and it was like you were just going with the brakes, it was like 10 kmph, it was like 5 kmph, and somewhere it was a open highway, and you are going with a speed of 120. Even it can be the case it was never 60 kmph, but this coming as 60 kmph. So you would ask, what is this 60 kmph and what does this formula stands for? If you had noticed, I used the word time interval. Actually, this speed is the average speed. Average speed. We'll discuss over our next video. Average speed. I take the concept time period, time interval. Okay then.